All right, let's get started. Hello, everyone. Hey, you're not too hungover? It's okay. Yeah, a bit. Okay, I'll try. So today I've got a lot of content to cover, and there's about 40 minutes of demos, but I just try to condense it a bit. So at some point I'm going to say don't blink because it's going to go fast. All right? So my name is Gael. Hello. I've been using DSC for a while. Who's using DSC around here? Yeah. Who's played with it and comfortable with it? Who's never touched DSC at all? All right, three of you. The good news is it's not that much about DSC in terms of it's not about the DSC resources, how to write codes about it. It's more about how to use DSC in a bigger environment. And obviously, we're going to use DSC resources. We're going to use DSC configurations and data. But I'm not going to go too deep into the code itself for this. I'm going to show you some of the bits of code. So this is a follow-up from last year's actually session from Steve Morosky, which is you need a pipeline. Who's using a pipeline? Module pipeline or something else? Yes. So it's just a follow-up. So he says you really need a pipeline to changes. And that applies to a module pipeline, but also applies to software pipeline, which probably your company does already. And that applies to infrastructure pipeline. So also, there's a very good white paper that he wrote with Microgreen, the release pipeline model. Who's read the release pipeline model? Not enough people. Everyone should have read it. So ak.ms, TRPM, and you're going to find the white paper from Microsoft. So that's a very good resource. And that's exactly the concept that I'm applying today. So what's a good solution? Because the talk is about a DSC solution, right? So what's a good solution? Well, the first thing is solving the right problem. If you don't solve the right problem, you can buy a very expensive solution, but if it doesn't solve your problems, you're going to say, well, this is not a good solution, right? So the key is to find your problem and try to solve it, whether it's DSC or any other configuration management. And this is not very specific to DSC. The concepts apply to every config management solution. And I like to remind this quote from Goldratt, from the theory of constraints. Any improvements not of the constraint is an illusion. So if you try to improve some local efficiencies, well, if it's not your constraint, it's probably not going to help you. So everyone's read the Phoenix project? Yes, that's much better there. So this is Brent, someone really skilled into like some areas of expertise like, I don't know, virtualization, Windows Server admins. Probably there's a lot of Brent around here. Used to be one. And the problem with Brent is he knows too much. So he's doing pretty much everything. He gets into a machine, RDP into the test environment. He wants to make some changes, effect some changes. And then what's happened next? Well, he needs to put that into prod. So he said, OK, that worked on test. Now I'm going to try to do the same thing in the prod environment. And sometimes it works. Hopefully it works. And if he doesn't, well, there's a quick outfix that comes, and then, oh, that version actually works. So the problem is Brent knows a lot, and he's the one RDPing into a machine, going in the test environment, making some changes, making sure that works, and then replicate that into prod. Most of the time, this actually doesn't work that well, because the changes in test are not really exactly reproduced in prod. You do in prod, you realize prod is actually not an exact mirror of test, and then you have some drift in there, and then you do a not fix, but only in prod. So over time, test and prod don't look at all the same. So the different problems you have is, well, the adaptability. It's very hard to change, because if Brent is not in the office, well, the systems he manages, that's never going to be changed, right? You need to wait for him to come back, or you don't even know what he did, because he just RDP to the box, and you can't see what happened. It's very hard to be predictable for those changes, because you rely on the human to make the same changes from test to prod. And this is why it doesn't work. This is why you've got a difference between test and prod. And at the same time, imagine, like you, he's a bit hungover or he's tired, and then maybe he's not going to do exactly the same changes, or not in the same order, or you may have a different system. At the same time, he knows so much that his cognitive load and working memory is really hard to manage, because he's the one that knows everything going on. So he needs to say, well, what's happening now? oh, I know exactly what I need to do. Just don't bother me. I can't work with you right now because I'm too busy, right? I'm too busy. So he's not happy in the end. And then is the single point of failure as well. See, you know the proverbial bus factor? Anything happens to Brent, everyone's screwed. And it's a collaboration challenge because then no one can help him because no one can just look into his brain and find out the information. And it's very hard for traceability, seeing what changes he does because he RDP to the box. And knowledge sharing is hard, getting feedback because test is not exactly the same as prod. And you create silos because he's an expert in some areas, but then no one else can even understand what he does, so people focus into another area, and then you create silos via different work centers. And that's really hard because then he needs to write documentation, but it's too busy. So to improve this, you need to get back to some principles, small changes. That is one of the key DevOps area that Jeffrey talked about. And you do smaller changes so that it's easier to manage as a work item. You version everything you're doing. That's why everyone uses source control, right? Hands up, please. That's fine, OK. And visibility, you need to see what's going on, and everything should be visible. So then you can, when you go home, you don't have to think about what's going on. Everything is written down somewhere, right? It's not about, oh, yeah, I need to write the documentation. I'll do this at the end of the project. No, it needs to be there while you're doing it. And then there's all the principles to go by. I'm not going to go too deep into those. High cohesion, low coupling. This is coming from, like, I'm not going to go into details, but look for it, especially in Wikipedia. There's a good article explaining what it is about. You want to be able to have different components that you just build together and then say, hey, that's a new system that works well together. But if you want to get rid of something, it's just about, oh, yeah, let's just throw that away. And then you want some baseline for non-regression, and you want to have your system, I'll get into more details later, but frictionless. Like, you don't want to say, oh, we need Brent for this change. And then you need to promote the changes. So it's not about Brent replicating the same changes twice. It's about doing it once and then making sure this is promoted in the environment from test to prod. If it's fine in test, then we can apply this in prod. And this is the only way to not have two different test and prod environment, which are different. You want some feedback. All along the way, you want to make sure that you have the monitoring, but it's not only about the monitoring. It's like, are you doing the right thing? And if someone has done a mistake, if they already done the same mistake, you need to know very quickly. So you're not repeating the same mistakes. So the idea is, as the human, you make a change. You want to build the trust into that change to make sure it's not completely stupid. And then you want that change to apply to test. And then while it runs test, if everything's fine, you build even more trust into that change. And then you want to get that change directly to prod. The human is on the left. He's making the initial change, but he doesn't have to touch it too much afterwards. So one of the two, so if you remember Jeffrey talking about the two keys of DevOps, the first one I'm going to focus on, the second one, not that much. The first one was making small changes more often. And the key is here. So this is called the dimming cycles. You can look in Wikipedia as well for an idea. It's probably what you're doing already. You plan to do something. You say, well, if I do this, maybe it's going to improve the system. And then you make that change. You check that the change you've done is correct. And then after that, you can go on to the next step. Don't forget the baseline. The baseline, and Glenn's going to go through in his talk about testing. This is where you say, well, this is the system where we're at. We don't want to go back. We don't want to be not as good as we are. We don't want any regression into what we're doing. So you need to have your test. So then you never go down. You always go up in the improvements. But you do it by small pieces at a time. And that's another very good quote from Dave Thomas, which is in his talk and his blog post, Agile is dead, long live agility. Find out where you are, take a small step towards your goal, and then adjust your understanding based on what you learn, and repeat. This is agility. It's as simple as this. Start now, and then make sure you look back to know if you're going to the right direction, and then always try to improve. So how to build trust and abstract complexity. The problem is there's so many changes, especially when someone remote desktop to a machine, that it's very hard to understand what's going on over time. You think it's documented, but over time, the difference between the documentation and what's really happening grows. The main problem is when you change. Let's say you run PowerShell. You use PowerShell. You do automation, fine. You still believe it's infrastructure as code, but you just run commands. It's much easier to document than clicking, right? It's better than the GUI. But you have to apply the same transforms to the different systems. Another way to do it is to make sure you create an artifact. And you build that artifact, which is unique. And then this is just a level of abstraction which says, well, the only thing you've got to do is to apply it somewhere. You don't think about the changes in the command. You just think about promoting the artifact to the different environments. I'm going to get back into artifacts. Right now, what's an artifact? It's something made by of art. It's beautiful, right? It's a work produced by human creative skills and imagination. The idea is it's a unit or entity. It's something you can manipulate. It's just a representation of something. And then it's created from human change. And its version, so it's unique. It needs to be tested because you want to build trust into those artifacts. And it's immutable because otherwise you're going to lose trust on an artifact. If someone changes it on the fly, well, do you trust it as much? You run the test, but someone changed it after the test. Do you still believe it's the same thing? Oh, but I know about it. No, the problem is you will lose trust. Someone changed it over time. So it's an abstraction. It's nothing that you're not doing already. It's just an abstraction. PowerShell module, to some extent, is an artifact. In your module pipeline, you have different files. You just make an artifact out of them. And then you don't think about all the functions, all the files you have in it. You think, oh, that's the module that provides the functionality. So it's just a way of abstracting. Think about an assembly line. This is where the pipeline comes from. You have different source files for your PowerShell module. And then you just put them into your pipeline. And at the end, what you get is a package, a module, which you can upload to an artifact repository like the PowerShell gallery. Everyone's familiar with artifacts? Not that many. OK, so if you have any question, feel free, shout. But that's the idea. So you have different source. It's not only one source. You have different source. And you put things together, different files, for instance. And in the end, you're going to start with a source. You build something. You're going to test it, build the trust, the QA if you want. And then you're going to release it. You may package it up and then put that into the PowerShell gallery. That is your assembly line. So you have your source. You put that into your pipeline. It creates the artifact that you trust. At least you trust that version. If something goes wrong with that version, what do? You go back to the source, change it, put that again into the pipeline, and go to the next. Another quote I like is, the pipeline applies its rules in a rigorous and emotional way. The pipeline is never hungover. You might be, the pipeline's never. If you don't trust something, improve the system, improve the pipeline, and then the trust is going to increase. Yes. So that's a representation of the pipeline, and that follows as well. I'll try, yep. So you've got your local source in Git, and then the source on your repository. I use Bitbucket for that example. The build, in that case, TeamCity. And this is test with Pester. That's something else I'm not going to cover today. If you want to have more control, you can have some fancy branching and pull request system with reviews and merge and build. And then when you're finished and you trust your system, you just release it. I'm going to show you a very quick demo, and I would like to highlight building best practices. You do that. I think it's today, 2 p.m. Beyond Pester 101 by Glenn over there. Hands up. Yeah, he's going to do a lot of good stuff about testing, which applies to everything. It's, you'll see, very interesting things. And there's also a build release pipeline model for mere mortals. It's more about the infrastructure. I checked with Ryan. And sample PowerShell module pipeline with the plaster. I have an article about this, which is going to be shown here in this demo. So it's going to be very quick. This is just a module pipeline to give you the principle. If I can start it. There you go. So the idea is, if Wust already has a release pipeline for modules. There's about 2 people. All right, this is going to get you started very quickly. It's a project I've done, which is a Plaster template, if you're familiar, so you can just do it. So this is how you would create your module based on that template. So you just invoke Plaster. You'd say, where is the module? And you create, you give it where you want the module to be. And then you type the name. This is my module. You put some description. This is just Plaster initially. And then you say, do you want to add a license, giving some features. In that case, I have different options you can have. This is just Plaster. And then you can quickly get started to have your system. That creates all the files for you. It's going to provide you some examples, some build scripts, everything you need to get started. And then you see the folder is created. So once the folder is created, you have the basic files. And you can already start building the module. All right, so I have a pause here. So these are the files that are already created. And if you know Warren's PS Cookie Monsters model, this is exactly the same model that he uses. So you have, this is the root folder of your module. You have build scripts in there. You have the entry point for the build scripts, some Git things. AppVeyor definition, which is already created for you. You don't have much to do in there. You can deploy. So if you want to deploy to the PS Gallery, you use, again, Warren's module PS deploy. And PS depend is if you have any dependency to use and to pull down during your build time, this is doing it for you. So very easy to do. You just have to follow Warren's lead. So when you call the build script, it resolves the dependency automatically. This is speed up because we don't have that much time. But that pulls every dependencies you need, and that's going to start building the module for you. The modules, so it cleans up the build. It loads everything. It already has pre-populated tests. This is only quality to make sure you have the documentation and you have some help files with it. This is running the unit tests. It compiled it for you already, and it's all ready. So because it's not running in AppVeyor, it's only in your local console, it's not going to deploy it. But then automatically, let's wait a bit. And then from there, you just have to run the same thing into AppVeyor to be able to create your module and deploy it. So this is GitHub. It's a bit small, sorry, I'm going to zoom out in a bit. This is just creating the repository. And then I'm just copy-pasting the same lines to make sure I push all this information that I have on my local machine, the module I just created. I push that into my repository on GitHub. I have to log in, obviously, because I use HTTPS in there. Pushing it. So now everything's on GitHub. Almost everything. I only push the README so far. To show you this, I refresh. I have only the README so far, so now I'm just going to use Git. I add everything, and then I commit this. This is my second commit, and then I push everything to the repository. And now if I refresh the page, I have all my files in there. So I've built it already locally, but you always want to double check in a neutral machine that it works on my machine, but it should work on someone else's machine. So we're going to use AppVeyor just to set it up quickly. And there we go. We create a new project. If you're already logged into to GitHub, you can just create an icon from AppVeyor, linking it to your GitHub account, and then you just add it. That's what I did. I just start the build directly because everything's already pushed to the repository, and you can start building it. Here you go. That's a bit bigger. So you're going to see that the build we did locally now is going to be replicated into a VM, spin up into AppVeyor, and you can just do the thing. So that's the principle of a pipeline. I'm going to let it run. Hopefully it's not going to be too long because I need to use, yeah. Let me just, yeah. So these are the tests you've seen. Running the test, everything's happened. And in that case, I didn't want to release that test module onto the gallery, but I released it onto AppVeyor as an artifact. So you're going to see in a second that this has been deploying somewhere. You have the test, which is the NewSpec XML, which is already loaded, and then the artifact. If you try this at home, that should work the same way. If it doesn't, let me know, but it should work. So you can have your release pipeline from tonight onwards, right? And you're going to need this for your infrastructure pipeline. So here, I just download the module. I just show you what is the module that you've zipped. You've got some tests, and then you've got a PSM1. And as a quick detail, so I compile every function files into one PSM1 file. All right, if you want to know more about this, talk to me later. So let's go further. So now that you've got your module pipelines, you build one for each module. You have one module running in one pipeline, another module into another pipeline, and when the artifact is created, you put that into your artifact gallery, repository, which is the PS gallery in that example, but most likely you will have your internal ones that you trust. So everything that you trust, because you run the test on it, because you know about the source, you put that into your artifact repository. A quick side note. So the evolution I'm trying to show here is the evolution of configuration management. We're not yet into config management, but that's going to come straight away. There's different, I like to see it as a different eras. And there's, if you think about versions, like version 0 is manual. Everything's manual, using the GUI to make changes. 0.5 is just scripted transform. So you have a deployment script, and you just run that script, which is much better, yet it could be improved. And then version 1.0 is policy-driven convergence. So that's a lot of things to say, well, that's the config management you know about Ansible, Chef, Puppet, DSC. And then if you go further, you have what I call the container model. And this is really about immutability. You create artifacts, and you run those artifacts, and you don't change the artifacts. If you need another one, just get rid of it, make the changes, and deploy the new one. This is really what you see in the microservices architectures, serverless, artifact everything. And then you'd only orchestrate the different artifacts. So that's a good model. The thing to know is it's very hard to jump between one to another because there's a lot of concepts that apply throughout. So you need kind of to understand what's going on in there. And if you're manual, going directly to policy-driven convergence is going to be very hard. You need to understand the basic of scripting. You need to have a module pipeline. So this is where you need to go through. If it's a greenfield project, well, if you're a developer, probably you're going to be able to go directly into container model because there's a lot of documentation. It's very easy to go. Most likely, every company is going to have a collection of those, depending on what they're doing and the area of the business. All right, side apart. So we've done module pipelines. So in theory, it's pretty much the same for the infrastructure pipeline. You have the definitions of your nodes and the roles they should apply. You put all these definitions into your pipeline. And then for DSC, you create artifacts, which are the metamorph, the morph, and the zip modules. These things need to be deployed into the pull server. That's the logo for Tug, just in case. And the metamorph needs to go to the servers directly. Tug is the open source pull server that Donjo started, and then some of the guys picked up. So what happens is, all your module pipelines create modules, which you're going to reuse into your infrastructure pipeline. That's why I spent so much time in there. You create the artifacts, and your infrastructure pipeline doesn't create new artifacts. They actually reuse those artifacts with some data. It says, I want this module, that DSC resource, that configuration. And then this is my nodes. This is the representation of my nodes. And I want to create all of those. You want to limit the change scope. That means if you change only one module, you don't necessarily need to change everything and recompile everything. You just change that module. And same with the data. If you don't change the modules, you only change some data. You want to limit the scope of the changes. So very similar. And this is, again, the release pipeline model. You have this source. And what's really important, I haven't mentioned yet, is the feedback loop. And the key of this, especially if you see to Glenn's talk, is that the further right you go, the more time it takes for you to get the feedback. Is something broken? Is it going to work? And then if you want to speed up the process, then you need to shift left the tests. The test that matters and the test that can tell you quickly what's going on, shift them left. So I'm not going to go into too much details, but if you want to go, I think Glenn's got a lot of very good information about this. So quick demo, let's get started. It's not quick. This one is long, but we can stop anytime. So very similar principle. And obviously, I reused the same code I used for the pipeline, but I did that for my simple infrastructure pipeline. So this is a control repository for DSC, if you want. What a control repository is just your definition of all your data and your reference to PowerShell artifacts like PowerShell modules, configurations. In that case, I use, again, ps-depend that you've seen earlier. And this is telling me all the modules I need for my build, the dependencies, and that's going to pull them down at build time automatically for me, like in a virtual environment. Hey, Warren is there. He wrote it over there. And that one actually fetching it from source control, which is really not something to do, but for a quick demo, that was easier for me. And that one is using the Chocolatey module I wrote to manage Chocolatey software, just for a quick example. You can see that there's nothing in the DSC configurations and DSC resources folder. There's no code in there. There's no module. The only code is the build source. The only thing I've got is some data. And you see, I use YAML files because they're very terse. It's very easy to represent information. So this is the DSC representation of a node with very basic information. And that's the same thing that you would create into a hash table when you use DSC. Just that I'd rather use YAML. But technically, with the tool I used, I'm going to introduce later, you can use JSON, YAML, or PSD1, all the same. So in the same way that we did before, we can build locally. And what it's going to do is going to pull all the modules you need. And it's going to create like a virtual environment, as you call it, which is going to reduce the PS module path to only what you've got into that repository, so you don't interfere with what you've got installed on your system. DSC is really bad at handling errors when you try to compile and you have some things installed on your system and you have some other things into your folders. So that just pulls, this is faster than it actually looks. So that pulls all the modules that I need for building. What it's going to do next is going to pull my dependencies, which is my DSC configuration and my DSC resources that I need for that project. So everything is defined in file. This is not in the GitHub repo. This is directly coming from the gallery. So this is running, if you're using this at work, it's going to be your own gallery that you trust. It's all about trust. And then it's going to pull, it just pulled the configuration, and then it's going to pull as well the DSC resource in a second. So what I call a configuration is not your traditional configuration. It's a DSC composite resource. I found DSC really bad at naming things. You have about 4 code constructs. Just remember, never use partial, only use DSC composite resource, and then use DSC resources for just managing some very specific objects. So this is the build script that builds your artifacts. And you remember the 3 artifacts that you need, especially in the pool mode. It's the MOF, the MetaMOF, and the DSC modules that are zipped up into a way that the DSC pool server can manage. You see that goes through my servers, and this is the configurations. I'm going to go into a bit more details in a bit. And that already compiled the MOF. It's compiling the MetaMOF very soon. It's also going to create for you the checksum. So you can already go home, do the same thing as you've seen in the video, git pull that project and build it. It's going to build your MOF. So it's not that difficult to get started with DSC. Well, that took a while to build. And this is the artifacts I was talking about. And the only thing you've got to do when you've got this is to deploy them to your build server. And then the MetaMOF needs to be used to set up your node. The only change we've done, you see in Git, is to the source. All of the things we pulled are not into the Git repository. Your control repository is only about the data and the reference to those modules. This is very convenient for debugging because you have all the source code in there, but you're not going to tamper with it. You're not going to change them. Next time you resolve the dependency, it's going to override those, most likely. So you see, this is the getting notes just to make sure you're not pushing this into your repository. Very important. Oh, yeah, that's an exclude of the README. If you look at the repository, the README's got quite a bit of information. So feel free to try it. And there's a video similar to that one. So this is the Chocolatey module, and you can see I pinned to a version, and we'll see as well in the configuration that I use it. So there's a bit of magic that I'm going to explain in a bit. So it took some time to build it, and you're going to see the environment variable right now for the PS module path. I'm just using the one which is there, except that because DSC, I would say, you've got to use also that one. But usually, when you install a module, it goes into program files, so it's not polluting too much. So that's a quick build. I already pulled all the dependencies. I don't need to do it again. So when you develop, it's much quicker to just run the build again. And I just rebuild all the morphs on the modules. The change of the configuration, you don't have to do too much change into the DSC code of the DSC composite resource. You just change the data. In that case, I make a quick change. I compile. So the change I've made was for when you use credentials. It should fail, but because I don't use anything with credential, it didn't fail, because I don't have the certificate attached to it. So that actually works. This is the morph I looks, and at the moment, there's only one thing in there. So what is a DSC composite resource, and what does it look like? Well, it's quite simple, actually. That's the simplest I could come up with, and it's just a configuration with one resource, which is a file resource. That's a basic example that you can have. On that one, it's just creating a file, making sure it's present, and it needs to be at a destination and have a content, which is the parameter of this. So if you want to see one which is a bit more detailed, I should be showing you the Chocolatey one, install Chocolatey, and then managing some packages, managing the sources, and managing your Chocolatey configuration. Yeah. So that's a bit more detailed. And it's the same principle. This is a Chocolatey resource. This is from the module I created. I pinned the version here as well, which I probably shouldn't do it there. The only problem is if you have two versions into here, because you didn't refresh your repository, then DSC, the PS desired state configuration.psm1 is going to not be happy. So the other thing I wanted to show you is I use some weird syntax here, just because if you're not aware, DSC doesn't support splatting. So using datum, which is the module I use, I actually emulate splatting. So that's why I call it get DSC splatted resource, which is similar to X is just an alias for that one. And you give it which resource name you want. Stop scrolling. And you see and then you pass the parameters that you got from that configuration. So it's relatively simple when you get this. And by using DSC composite resource, it's quite easy to compose them together. I'm going to show you the DSC resources themselves in a second. You can see this is the Chocolatey package one, and you have Chocolatey settings, Chocolatey feature. This is the different DSC resource to configure, especially a Chocolatey for business environment. And then it installs all the packages you tell it to install into that configuration. So the benefit is when you have this, for every node, you don't have to rewrite a different configuration. You just give different data based on the node. So this is the different resources I was talking about. And then this is how they look like. You have the get, the set, and the test. And this is normal DSC script resource or morph-based resource. And they're just calling commands that are coming from the module, actually. So this is the one I created, but you can have any resource from the gallery. So there's already a few hundreds, at least, if not thousands. And we can look at the morph we created for server 02. And server 02 is only a bit of data. Let's go back up. I probably need to speed up as well. So this is the morph file. And you can see this is the instance of the Chocolatey software. and the chocolatey source. There's not that much into it yet, so I'm not setting up packages, for instance. So let's look at the configuration data. And for that server, it doesn't define any of those. So it actually defines a role, which is Windows base. So we're going to open the role and see what is defined in there. So Windows base, open on the side. There you go. So you see there's different configurations here, which actually reference to the DSC composite resource we imported. And the problem is the packages one is not in the right indentation because of YAML. So that's the only downside of YAML, is you need to have the right indentation to get the right structure of data. So the packages here are not used for software base. So I'm going to show you how to change it. That was actually intentional. So I'm going to change the indentation here to make sure it's under software base, which is the configuration defined here. And this is, if you change a role, this is the kind of change you're doing. You're only changing the data, not DSC configurations. Much easier. And then you recompile. I change nothing else. And then I'm going to look at the MOF file. So you've seen the compilation. You see that you can compile very quickly, very often. The more nodes you have, the longer it takes. So you need to split them up. That's why there's a filter node, to make sure you compile only certain nodes. These also give you some feedback about what's going on, what is being compiled. Recompile those. We're going to look at them directly. There we go. Come on. So now we have the same thing that we had before, the chocolatey software, the chocolatey source. That was already there. But if you look down, we also have the packages. So the 3 packages are here. And we only change the data. Only the data has changed. So the data is what matters to your business. You have one role. You want to make sure that role applies to many machines. You don't want to edit and repeat yourself. So what if, I think it's the next thing, what if you want to add a new node with the same role? Well, you just assign it to it. So very quickly, you create a new YAML file, in my case. I literally copy-paste, changing the node name. Yeah, the description was wrong, never mind. So I just fixed the description. I use the same role, as you can see here. Everything's fine. I don't need that property. I don't use it. I just recompile again for the, I don't know, 5th time already. And that's going to create me a new node, and everything's going to be populated the same way as it was for the other one. DSC is not difficult. I'm just changing text files. Who can change text files? Everyone. Yeah, exactly. And if you're not familiar with YAML and rather use PSD1, then you can as well. And nothing changes. The data is already handled by the module I use. I'll show you an example maybe later if I got time. Probably not, actually. So that's as much as we changed. We only created a new file, and I recompiled the new MOF. So what's happening under the hood? Just giving a bit more details. So this is the actual PowerShell running, and there's not that much of it. What's happening here is I created a configuration, and you see the reference to my configuration in there. This is the problem, is you can't do that dynamically with DSC yet. This is error handling, because DSC is a bit annoying with the errors, so I'm just making sure I display only what you really care about. And that's pretty much it. You have your node configuration, all nodes node name. And then within this, you look up the configurations. Oh, let me pause here just for a second. Who's been to Mrs. talk yesterday? Only one. All right. So in Puppet or in Chef, they use very similar principles. And actually, it's the opposite. I use exactly what they're doing. I just completely rewrote it exactly the same way as role and profiles in Puppet, which is really well documented. And the idea is I call it slightly differently because of DSC. So it's more configurations and roles. And what you're doing is you're making sure you have the configuration. In Chef, it would be run lists. You know, you have a role and you have run list. That's the same principle. In Puppet, it would be roles and then you have profiles. So let me just quickly carry on. And then I just look up, for that particular node, I look up all the configurations it needs to apply, and look up at all the properties it needs to apply. And I just do the same thing as splatting. I just splat everything to that configuration name. So that's just a dynamic way. You never have to change it. You don't even have to know it's there. It just builds it for you. If you want to be a bit more, to change more details in there, you can, like changing the error messaging, but technically you probably don't need to. Everything you need to change is importing the right configurations, importing the right resources, and changing the data that compose them together. This is the composability model. This is just DSC splatting. I have an article, if you want to use it outside, I have an article in my blog post about how to do this. And there's a problem with scope that really got me a couple of days. So, yeah, configurations, run list, classes. These are the different, I use configurations, and Chef and Puppet have different names. And actually, Ansible is the same with, I think it's roles and playbooks or something like this. So this is the parameters. You have the configurations, what to apply, and then what parameters to send to the configurations. And you will see I'm going to show you how these maps to the configurations that we've seen earlier. I'm taking the software base, which is configuring Chocolatey. And that just mapping directly. You see the parameters there are just mapped directly to those parameters. So you can add settings, which I haven't there, but I could define the settings. And I have a few more minutes. Any questions so far? No? So if you want, just a quick one, this is only if you want to pin a package version. This is hash tables. It's just YAML for hash tables. So you just add a new property, which is used into that resource, which is Chocolatey package. And you say, well, I want a specific version. And I want not the latest version, I want version 0.10.8. You add this, only the data, you recompile, and that's gonna specify this version into your MOV file. By default, this version, you can't see it there, but it says by default use the latest one, the latest on the NuGet feed. So if you try, you just clone that repo, you should be able to just build MOVs already. It's not done, but as an example, we've been using an SMB pool server. Like that means you just put your MOV files on everything into a SMB share, and then you can have your nodes just talking to it and pulling the information and setting up into your machine. The same way, very similar, we set up the LCM config. And as you can see, this is if you want to use SMB share. You need to use GUIDs for node name, but if you've seen on the file, it doesn't change much. And this is very similar. This is the way we build all the MOVs using the configuration data. So you don't have to touch that ever. It's already there. You may have some conflicts, and DSC will tell you you're missing these settings, but it's already done for you. I think that's it. So, not covered. Or not to be a jerk to your coworkers. That's the second part of DevOps, according to Jeffrey. And there's a lot of work methodologies that really goes well with that kind of attitude, that kind of methodology, because everything is visible up front. Every change is going through a pipeline. So that means you have traceability of everything, and you have self-documentation. You know what your roles are. You know where they apply to. So it's much easier to manage. Quick changes is very easy because you reduce the scope of changes by just the size of your file. If you want to, so the visibility you create by those files makes it much more easier to manage. There's things I haven't covered. Operation validation, I think Brandon is over there. Hands up at the back, look at him. This is a very important subject. He is the maintainer for OVF, which is the Operation Validation Framework, which is when you've done this, if you deploy it to a node, then you need to validate it. I'm not covering this because obviously running out of time, but this is a very important topic. And there's some other things, POSH-spec, inspect, server spec, which is coming from different communities, but they would work the same way in your environment. You just probably need to learn the tool. So it's the same with OVF. OVF is based on Pesta, so maybe more familiar, but do look at the other ones. I haven't shown release and staging, but since you build all the artifacts, you can stage them to say, well, I'm creating those for dev, prod, and then all the staging environment. And then you can release them, so copying them to the pull server only at the times you want. Orchestration, notification, I'm not going to get into the details. And then pull server reporting. This is, people believe they need to have the whole solution to get started. Probably not. I'm sure you already have some monitoring. Using code to configure is probably going to be better leveraging the existing monitoring you have. You can just change the way you make the changes and keep the same way you're doing the monitoring, and then you're going to improve the monitoring when you get the bandwidth to actually make those changes. And the inventory as well is not covered. You can find me GitHub. So all my projects, all the things you've seen today are here on my GitHub. Feel free to link LinkedIn. I have a blog, gaelcodes.com. I have a lot of documentation in there. Everything else is in the repository. And you can tweet me on, I'm a co-organizer for PowerShell Conference Asia. So if you fancy coming to Singapore at some point, yeah, give me a shout. Thank you, Chef, Puppet, Ansible, for all your work, because I took pretty much everything. If you understand those principles, you can reapply them to Puppet. You can reapply them to Ansible and to Chef. Exactly the same. The only thing I've shown you is how to use DSC, because you may be more familiar with DSC. But if you understand the principles, it's fine. So the key thing I want you to understand from here is, if you're still asking which solution is best for you, you're missing the point. You should start somewhere, and start now. And then you understand what are the differences between the products, and then you're going to be able to say, well, actually, this doesn't really work for me, and I need to go there. When you get the problem of reporting for DSC, you're already 6 months, 12 months ahead. Get started now. And that, hopefully, this project's going to help you getting started very quickly, because you only start composing, and then you're going to be able to experiment from there. A lot of very informative people to follow in there. If you want good information, just go on Twitter and follow these guys. Yeah, if you want to read more about DevOps principle I was talking about, definitely check Steve's DevOps reading list. This is what I read, and there's about, I don't know, 20 books or so, really good for this. Thank you.